Welcome everyone. In this video I am going to discuss two problems that is similar to question number 5 and question number 6 of your homework number 3. Let's begin the discussion from this problem. In this problem you have to find all points of intersection r theta of these two curves. R equals 6 cosine theta, r equals 6 cosine theta, and r equals sine theta, right? So in this type of problem, the first thing that you have to do is sketch the given two curves, right? So what is the shape of r equals 6 cosine theta? We discussed these two shapes in the class. So r equals 6 cosine theta is something like this, right? And what can you say about the coordinate of this point? It is going to be 6, right? And if you consider r equals sine theta, this is the shape of r equals sine theta. So the y coordinate of this point is going to be 1, right? Because when theta is going to equal to pi divided by 2, then sine pi divided by 2 is going to be equal to 1. That means at theta equals pi divided by 2, r equals 1 if you consider this curve, right? But if you consider r equals 6 cosine theta, then at theta equals 0, you get your maximum distance between origin and your point, right? Okay. Now after you sketch these two curves, you can see that they are going to intersect at 2 points, right? This is one point and this is another point. This is the origin. That would be okay, right? But our target is to find the coordinates in polar form of point P, right? So what would happen at point P? To locate point P, as I mentioned in the class, you need the distance between origin and your point P. This is your origin and this is your point P. You need this distance to locate your point P. And also you need this angle. You need this angle, right? That's why I mentioned that angle as theta naught, right? So this is the line which represents theta naught, because we know that if you consider any point that is lying on this line, your angle is theta naught, but you do not know the radius or r, right? So our target is to find simple r and theta naught, right? So let's consider point P, right? At point P, you will get the same r value from this function and this function, right? Therefore at the point P, I can say that sine theta naught is going to be equal to 6 cosine theta naught, right? So if I divide both sides by cosine theta naught, I will get this expression, which is equal to tangent of theta not equals 6, right? So then from the inverse function, I can evaluate the value of theta naught, right? So I know that tangent of theta naught is going to be 6. So theta naught is going to be tangent inverse 6, right? So if you use the calculator and evaluate this value, you will obtain this value in radians, right? And be careful when you are finding the inverse trig functions, right? Always check that your calculator is in radian mode or not, right? So because we are interested in radians, right? In polar form we are interested in radians, so theta naught should be in radians, right? So I found theta naught. I hope up to that point it is clear, right? Okay, now I know the value of theta naught, right? That means I know this angle, right? Okay, now how do you find the distance between origin and point P? Now I know the angle, and this formula gives me the relationship between angle and the distance between origin and point P. Now I know my angle, and if I plug my theta naught to this function or this function, I can find the distance OP or R, right? Okay, so that's what I'm going to do next, right? So this is my point of intersection R theta naught, and but I know that R is at theta equals theta naught, R is going to be equal to sine theta naught, right? And this is theta naught, right? So this would be the coordinate of your point P in polar form, right? So this value would give you the R, and this is the angle in radians, right? Okay, now our next task is to find the area of this highlighted region. This is the area that I need to find. Okay, first thing that you have to realize is this area is the summation of two areas. So I will use another different color. This area is a summation of these two colored graphs, right? Green colored and the other color is kind of pink, right? Or brown, right? That colored graph, right? So how do you find the green area of the green colored graph? So if you consider the graph of R equals sine theta, because if you consider this curve, it is the curve R equals sine theta, right? So you have to evaluate the area trapped between R equals sine theta and theta equals theta naught, right? So your angle is going to be varying from 0 to theta naught, right? Because you have to collect sectors starting from 0 to theta naught. And what is your R value? It is given by this function R sine theta. So I will get the area of my green colored region as this value, right? Because 1 divided by 2, R is sine theta, sine square theta, d theta, and the value of my theta naught is tangent inverse 6, or in other words, this value of radians, right? Okay, now this is the area of green colored region. I will write that down. This is the area of green colored region, right? Now what can you say about the other part? Now if you consider this region, now your bounds of your integral is theta naught to pi divided by 2, because you are going to start collecting sectors at theta naught, and you are collecting like this, and you reach pi divided by 2, right? So bounds of my integral are tangent inverse 6, which is equal to theta naught to pi divided by 2, right? Okay, now what is the area of the sector? That is given by 1 divided by 2. Now your curve is going to be this curve, right? Which is given by this function 6 cosine theta, right? So R square will be 6 square cosine square theta, right? This is your answer to the first problem, right? Then you can use a calculator on some online calculator to evaluate this integral, right? Okay, that is my first problem. Let's move into the next one. In the next problem, you are asked to find the intersection points of lemniscate and the circle R equals 3. And this is your lemniscate and this is your circle, right? For the values of theta satisfying this condition. So your theta is in between negative pi divided by 2 to pi divided by 2. Negative angle is negative means you are measuring your angle in clockwise direction. Angle is positive means you are measuring your angle in counterclockwise direction. Okay, so again let's consider the intersection points, right? Now we are going to intersect at this point and this point, because actually we are going to intersect in the other points also, but we are not interested in them, because in the problem you are given that consider only this region, negative pi divided by 2 to pi divided by 2. So we are interested in this first and fourth quadrant, right? Okay, so again, another fact, if you can find the coordinates of P1 in polar form, then you already know the coordinates of P2 from the symmetry, right? Because the distance between origin and P1 is same as the distance between origin and P2, and this angle theta 1 is going to be same as this angle theta 2. But since I am measuring theta 2 in the clockwise direction, that would be negative, right? Therefore, theta 2 is going to be equal to negative theta 1, right? In magnitude, it is equal to theta 1, but since we are measuring in the other direction, theta 2 is going to be equal to negative theta 1, right? So what will happen at P1? At point P1, we can equate r square, right? In other words, r square is going to be equal r square, right? Okay, so then on the one hand I'll get 9, and on the other hand, because r equals 3, so r square is 3 square, and on the other hand r square is going to be equal to 36 cosine 2 theta 1, because at point P1 my angle is theta 1, right? So if I simplify, if I divide both sides by this 36, I'll get cosine 2 theta 1 as 1 divided by 4, right? So by taking the inverse function, 2 theta 1 is going to be equal to cos inverse cosine 1 divided by 4, right? So then if you simplify, you will get theta 1 as this angle, that is 0.659058 radians, right? Now you know theta 1, right? Now you know the angle of point P1, and also we know the distance also, right? Because point P1 is lying on a circle whose radius is 3. Therefore, the distance between origin and my point P1 is going to be equal to 3, right? So how do you write the coordinates of P1? That is going to be equal to this, right? R is going to be equal to 3, and angle is going to be equal to theta 1, right? And if you consider P2, again R is equal to 3, because as I mentioned earlier, from symmetry, the distance between origin and P1 is going to be equal to the distance between origin and P2, right? So this value is 3, and since you are measuring angle in the other direction, the angle of point P2 is negative 0.659058, right? Or in other words, you can say that that angle is going to be 2 pi minus 0.659058, right? So I think Weber might accept this answer. So if you, after you find the angle value of point P1, use its negative value as the angle of point P2, right? So check with this answer also. I don't know what is the best option for WebWork, right? I hope WebWork might accept this answer, right? Okay, I hope you understood how I did these two problems, right? And if you have any further questions, you can send me an email. Okay, I'll stop the recording from here.